All right, so how do we do this? This one's really simple, this first one. The trick to this stuff is if it is a difficult, like a difficult one with lots of transformations, then you got to go through the whole step-by-step process. You got to do all the different properties. Think about amplitude and everything. We're still going to do that for this one, but it'll be easy. But the reason why this is so much harder is because when you get to the end, we have to figure out our scale. Okay. Now I'm actually giving you what to use as a scale. So all you have to do is basically figure out how many squares you're counting to get to the next point. That's your goal, as well as put together the rest of the properties. Okay. So let's go ahead and start. There's the only thing that's changed here is the k value, so I'm going to skip the other ones for now, and k equals 2. A is 1, C is 0, D is 0. Okay? But I'm still going to write out the properties. So my amplitude hasn't changed, so it's 1. My 0 line hasn't changed, so it's y equals 0. That means my max, I go from the 0 line up the amplitude, and my min is the 0 line down the amplitude. Then you always think about your start, which in this case is 0 because it's just, there's no shift. And here's the new part from Friday, and the probably the trickiest part of all of this is figuring out working with the period. You got to know this formula, which is 360, the regular period. So we know that number is the regular period divided by the k value, which in this case is 2. Do that on your calculator, or if you have to, it's 180. Then, as we just talked about, again, this is the part that you just have to know what to do, and I explained why. We have 5 points. So after the first point, there's 4 more points. And that breaks this graph up into 4 parts. So we take the period and divide by 4. Now, I take this number here, which is 45 degrees, and that means my next point after my start, which in this case is 0, my next point will happen in 45 degrees, whatever that means. It's not going to be 45 tick marks because we don't count by ones. What are we counting by? This says 4 squares is 45. So that means 1 square is like some decimal, 12 something, which we don't really need to know, but that's what it is in this case. But because this is 45, that just means 4 squares. That won't always match. It's not always that easy. The first one worked out that way. Okay, and then I take all the pieces, the 0 line, this is cosine, so it starts at the max, no reflection. The 0 line and the max and the min, where it starts and how many squares to get to the next one, as well as my understanding of cosine in general to put together this graph. Now we got to add our scale, and this says 2 squares is 1, so I'm going up 1 and down 1 to negative 1. And 4 squares is 45, so 1, 2, 3, 4 is 45. Now, I hope this works. Hey. Zoom in a little bit here. Okay, so I go 45 plus 45 equals 90. So my next one, 1, 2, 3, 4, happens at 90. Then I go plus 45 more. Whatever you're counting by is 135. 1, 2, 3, 4 is 135. And then I could just start hitting equals. 1, 2, 3, 4. And the rule of thumb, my rule, I should say not rule of thumb, my rule is your scale has to go at least as far past your last point. So you can go all the way to the end if you want. If you stop partway through, and then one of your points ends up just past there, then you should put another measurement on. In this case, I think 180 is going to be enough, right? Because we start at 0 and we're going 180. So in this case, we're good. So cosine starts at the max. We're counting 4 squares to find the next point. So here's the max of 1. That's what we calculated. Then I go to the 0 line, which is y equals 0, 1, 2, 3, 4. Then to the minimum, 1, 2, 3, 4. Back to the 0 line, 1, 2, 3, 4, because we just know this is what cosine looks like. And then back to the max, 1, 2, 3, 4. And again, see how I go out sideways? It's kind of straight through that one, and aim to come in sideways on this point, and then back up, and then again come in sideways. Doesn't have to be perfect, but it does have to be curved. It can't look straight, and it can't look like straight corners. Any questions about that? Oh, and I love to do this. In this case, it's not necessarily as useful, but this is a good trick. Is after I'm finished, I go back and I go end equals where you started plus the period, which is in this case 180. Did I end at 180? I did. So basically, I've done the period stuff correctly, and I've started in the right place. Now, whether you got the shift right or the 0 line right or wrong, the amplitude, that's different maybe, but at least that's a check for a lot of the work. All right, on the back of your page. All right, so this one's got a lot more going on. In fact, it's got a little bit of everything. So we're going to start by writing out all of these values. Again, you don't have to do this, but it's a nice first step. A is -1. K is a half or 0.5. It's often written as a fraction, but if you want to think of it in terms of a decimal, then that's fine. And then C has the opposite sign of the number in the bracket. So in this case, it's plus 45 or positive 45. And D is 1, plus 1. All right, amplitude is still 1. Amplitude is always positive. This is a small thing, technicality. It's not probably super important to us. You would draw it, even if you wrote that wrong, you would draw it the right way. But technically speaking, amplitude is always positive. Okay. 0 line. Y equals 1 because of the D value. That means my max is from the 0 line up 1, goes to 2, and my min from the 0 line down 1 is 0. Then I do my start, which is 45. And then we're going to start the work on the period. Again, it's always 360 divided by the K value. So 360 divided by 0.5, and I would encourage you to use your calculator for this. Some of you might be able to do it in your head. We see the same ones come up a lot. So you might kind of learn some of them, but make sure you know how to do this on your calculator, either with a fraction or as a decimal. Sometimes you can't use a decimal. I think there's one in the practice that's like that, because it's a third. You can't round it. Okay. So this one works out to 720. So this is a stretch. We've got a big period. So I take 720 and I divide by 4. The same steps every time, right? There's a lot of steps. There's a lot of pieces to it. But it's the same steps every time. And that works out to 180. And here's the tricky part. If my x scale is 2 squares equals 90, and the next point happens at 180, you have to put 2 and 2 together, and literally, I guess in this case, and figure out how many squares to your next point, and that's how you want to write it out. So how many is it going to be in this case? It's not a tricky one, and once this starts to click, they're usually pretty straightforward. Some of them might be a little bit harder, but... Zach? 4 squares. Because 2 squares goes to 90, but I need to go to 180, so I need to go double that. So therefore, 4 squares. Okay, now we got to draw out the graph. So 2 squares is 1. I'll do that first. So I go up 1, up 2. And remember, my max was 2 and my min was 0. So I really only have to label those couple. You don't have to go and label the negatives. But, you know, you might want to put 1 there or something. I don't know. And then it says 2 squares is 90. So I'm going to go like this, 90, 180. And just kind of label every other because it'll go a bit faster. So 180 plus 180 is 360. So another 2 and 2 is 360. Plus 180 is 540. So there and there, 540. 720. And I got to go one more to 900 because my last point's going to go just past 720, I think. Everybody good? One thing we forgot to write down, there's a reflection. I always go back when I double check which one I'm graphing, is it sine or cosine? And I always look back to see if there's a reflection. This is just me. It's probably a bad habit, but I ignore it at first. I kind of forget about it. But then I make sure I got to go back and remember to check. That's why I forgot to write it down. Okay, so sine starts on the 0 line, whether it's reflected or not. I've got to shift to the right 45. Where's that point on this grid? 2 squares is 90, 4 squares is 180. Where's 45? Again, this is something we have to be able to think through. How many squares? Pearson, do you know? 1 square. Sine starts on the 0 line. My 0 line is y equals 1. So I go to y equals 1, which is my 0 line, and I go 1 square over, because this is 40. This would be 45. You don't have to label it. I'm just showing my thinking. It's a reflection. So from here, I'm going to go, how many squares did we say? 4 squares. And I'm going to go to the minimum, which is 0. Again, all of this is written out. If you've done your work, all of this is written out. The number of squares, the max and the min, and the 0 line, and the start. 1, 2, 3, 4 to the minimum. 1, 2, 3, 4 back to the 0 line. 1, 2, 3, 4 to the max, which was 2. 1, 2, 3, 4 back to the 0 line. Nice. 1 cycle, that's the other thing I forgot to, some people are going past it. You can, it's not wrong, but usually we're just trying to draw 1 cycle. Those 5 points, you don't need to go back this way, you don't need to go the other way. Sometimes we do. Sometimes we draw more than 1 cycle, but what we've been practicing is just drawing 1 cycle. Any questions? So the last thing I'm going to do is I'm going to go check my work. So if the start was 45, the end should be 45 plus 720, which is 765, which is a little bit hard to tell on my scale where that is. But if I think about how this is 720, and I added 1 square 45 to it, that's 765. So we finished just past 720. So I'm good. Any questions? Okay, I want you to try the next one. Whoops, I passed it. Sine again. None of these were cosine. We didn't get to practice any cosines today. Should have made one of these cosine. Okay, I want you to get started on that one and see how much you can do. Okay, this looks really good. People are moving along with this, so I'm going to do a little bit of catching up here. But you keep going, and then you can check your work against mine. Oh, I forgot to point out, I changed this question. Did you notice that yours says plus, but mine says minus? I hope I caught that in time. So that's going to change something a little bit. If you don't do that, in this case, oh, it's fine. If it's fine. I also changed the x scale to 4 from your handout. Your handout says 2. I changed it to 4. So if you can catch that in time, do it. If you can't, it's not the end of the world, but your graph will look a little bit different, but I can come around and take a look at it. I just thought this one would fit a little bit better. With the other scale, it worked out to a 1 point every 1 square, and that's like really small graph. We try to avoid that. Big change in amplitude really stretches it out, and because I've shifted down 1, that's from that point is where I'm going up 3 and going down 3. All right, so here's my work so far. My period is 180 degrees, is similar to the other one that we did before. Divide that by 4. Always divide by 4. Again, some people question that because they say when they're first learning this, they divide by 3 for another question and 4 for another question, or something like that. Always divide by 4. Then once we've got that work done, we have to figure out how many squares this is. That's our formula. Our formula for the period, I'm going to write this down over here off to the side. The period, so this is something you just need to memorize. It's 360 is the regular period for sine and cosine, right? We talked about that. And you always divide by the k value. And the k is 2. Okay? Okay. So I'm going every 45 degrees. 4 squares is 90. So how many squares am I counting to get to my next point? 2. Very good. Therefore, 2 squares. I've said this to a lot of you. I may have even kind of told everybody, like, this seems really overwhelming when you first see it. But once you start to recognize that it's small steps, little bit step by step that come together, it's doable. And you start to be like, yeah, okay, I'm seeing how this process works and how it all makes sense when you put it together. Yes? Yeah, that's right. If you didn't change it, if you're working as every 1 square, which, like I said, makes a really small graph, it's hard to draw. We usually try to stretch it out a bit more than that. That's why I changed it afterwards, but I forgot to tell you. Sorry. All right. So we've got our 0 line at -1. Oh, I've got to do my scale. So 4 squares is 90. So that's 45, 90, 135, 180. And 270, 360. And how far are we going? Oh, we're going over. Our period's not very big, but we're shifting that direction. I'm going to go a little bit further. Probably this is enough. And 1 square is 1 on my y-axis. So 1, 2, 3, 4, -2. Sine again starts on the 0 line, which is -1. Oh, I got to go down a bit more on this scale. I forgot. -4. And I'm shifting to the right 90. So I'm going over 90, and I'm going down to the 0 line, which is -1. Again, I need my max and my min, my 0 line, my start, and the number of squares. And I found the start, and then I'm going up. There's no reflection, so I'm going up to the max after 2 squares. And that's 1, 2, 3, my amplitude of 3. 2 more squares back to the 0 line, down to the minimum, 1, 2, 3 down, 2 squares over, back to the 0 line, 2 squares. Small one. And then my check is my end, which is where it starts, plus the period. This is also just a good thing to think about for periodic functions in general. That works out to 270 if I do that on my calculator. 90 plus 180 is 270. And why does that help me? Look at that, 270. Beautiful. I'm just going to show this one more time. We looked at this on Friday, I think. Okay, let's take one more look at it. And I'm going to do it for this graph. So A was 3. D was -1. C was 90. And K is 2. But what I want to show is how this is the amplitude, up 1, 2, 3. This is a different scale from the one we were looking at, right? There's my amplitude. And that's a common mistake that people make, is they forget that the max and the min are from the 0 line. As I move the graph up and down, I move the 0 line, the distance from there to the amplitude doesn't change. It's always the same.